Alright guys, let's take a look at your review packet. Number 1, we know that measure of interior angles of a quadrilateral is going to add up to 360. So all you have to do for this one is take 360, subtract 109, subtract 71, subtract 66, and your fourth angle should end up to be 114 degrees. Okay, next one, you've got a parallelogram. One thing that we know about parallelograms is that opposite sides are congruent. So they're looking for BC. BC is going to be 7 because the side opposite is 7. We know that DC is 16, so the side opposite, AB, is also going to be 16. Okay. Number 3, we know opposite sides are congruent, so we also are going to know that opposite angles are congruent. So it says DAB is 105, therefore we know that BCD, the one opposite from it, is also going to be 105 degrees. Okay. If in your picture, if you label your stuff, you know that NM is going to be x plus 7. You know that OL is 17. We just talked about opposite sides being congruent, so set them equal to each other. X plus 7 equals 17. Subtract your 7 from both sides, and x equals 10. Okay, number 5, we know that D is 73, B is 73. We also know that consecutive angles are going to be supplementary. So they are going to add up to 180 degrees. So if we take our 180 minus our 73, we're going to get 107 degrees for both angles. A and angle C are going to be 107 degrees. Okay, this one you probably had to dig for, so I'm pretty sure that none of you actually have this problem done. The mid-segment of a trapezoid is the segment that connects the midpoints of its legs. So if you have your trapezoid that looks like this, midpoints of its legs, connect them, that's going to be your mid-segment right there in the middle. Okay, your formula for your mid-segments, this isn't on your formula sheet, so you might want to add this to your formula sheet. I will allow you to use that on your final. So somewhere on there on your formulas, mark it mid-segment of a trapezoid formula. Okay, and it's going to be 1/2 of your base 1 plus your base 2. Okay, it's just averaging out your bases. So in this case, we're going to go 1/2 times 12 plus 22, or 1/2 of 34, so x is going to equal 17. Again, add this formula to your formula sheet, because if you come on Thursday and you complain that you don't have this formula, I'm not going to feel badly for you. Okay, same thing here. Label AB is 12, DC is 16. Find the average for your mid-segment. So 1/2 times 12 plus 16 is going to be 1/2 of 28. EF is going to be 14. Okay. Again, parallel here. So we have a trapezoid. We know that in a trapezoid, our consecutive angles, whoops, not those two angles, sorry. Our consecutive angles are going to be supplementary. So these two right here and these two right here are going to be supplementary. So for A, it's going to be 180 minus 61. Angle A is going to be 119 degrees. And here we've got 180 minus 125, and angle B is going to be 55 degrees. So your angles that are on the same side from each other are going to be supplementary. Okay. Number 10, proportions. Okay, to solve proportions, we're going to cross multiply. So in this case, we're taking 5 times 54 is going to equal 6 times, k plus 3. So this gives us 270 equals 6k plus 18. Subtract your 18 from both sides. 6k equals 252. Divide by your 6, and we're going to get k equals 42. Okay, your other two portions are the same way. 2 times 126 is going to give us 252 equals 7 times b plus 7. So distribute that. 252 equals 7b plus 49. Subtract your 49, we get 203 equals 7v. Divide by your 7, and v is going to equal 29 on this one. Okay, number 12, again, 3 times 15 gives us 45 equals, distribute this, so 5d plus 10. Okay, subtract your 10. 35 equals 5d. Divide by 5. D equals 7. Okay, similarity. Okay, this one, I know you guys didn't like this chapter very much. So remember that your sides are proportional. So in this case, 4 over 10, because those are the two sides that go together, equals, if we start with this polygon on top, it's got to stay on top. So 4 was on top, so now 6 has to be on top. 6 over x. Now we cross multiply. 4x equals 60. Divide by your 4. X equals 15. Okay, and that goes along with all these. They want to know, are these similar? Okay, if they're similar, all the sides are going to be proportional. So 10 over 15 has to equal 12 over 18 has to equal 16 over 24. So if you go through all these and put them in lowest terms, you get 2/3 equals 2/3 equals 2/3. So yes, they are similar. Okay, we need to write a similarity statement. So triangle QPR is going to be similar to triangle, what goes with Q would be B. So triangle B, P goes with A, and R goes with C. So QPR is similar to BAC, and then the scale factor is just going to be your ratio in lowest terms. So 2/3 is going to be what our scale factor is in this problem. Okay, so now we're going to use that scale factor to figure out other sides of another triangle. Remember, this triangle is tilted a little bit, so we've got to find sides that go together. So 16 goes with 32. So 16 over 32, if we put that in lowest terms, we've got 1/2. This is going to be our scale factor. So now we can go with 1/2 is going to be equal to 10 over x. Cross multiply, 1x equals 20. So x equals 20. Okay, and then same thing to find y. 1/2 is going to equal 13 over y. Cross multiply, y equals 26. Okay, could have done the same thing without putting it in lowest terms. You could have gone 16 over 32. And when you cross multiplied and solved it, you should have come out with the same answers. Okay, triangles, are they similar? Well, you have to go through all of your different ways triangles can be similar, but in this case, we've got angles. So if we find this third angle here, so 180 minus 81 minus 23, this angle is going to be 76. If we do the same thing over here, 180 minus 81 minus 76, this angle is 23 degrees. Okay, they are similar, so this one's going to be yes, and they're similar by angle, angle. Remember, we didn't need angle, angle for similarity. We used angle, angle, we used side angle, side. We used angle, angle side. Okay, lots of different steps that we can use in similarity. We can even use ASS, which you are not allowed to use in congruence. Alright, so are these similar? Okay, if we remember, we've got parallel sides, and this is kind of where I freaked out on you guys because nobody would remember about our angles. So we have angle D is congruent to angle B, angle ADE is congruent to angle ABC because why? Corresponding angles. I know it kills you guys to remember corresponding angles. Okay, the other one that we can use, we could do corresponding angles here and get two angles congruent to our triangles. Okay, or we have A up here is going to be our shared angle. Okay, so triangle ABC is similar to triangle ADE, okay, by angle, angle, because of those shared angles. Okay, so now we go to this one. We've got to figure it out. We've got one angle, but in order to use side angle side, we also need to know, are our sides going to be the same ratio? So is 11 over 8.8 the same as 12 over 9.6? So 11 over 8.8 gives us 1.25. 12 over 9.6 gives us 1.25. So yes, they're similar by side angle side. Now we have to look at the similarity statements. A goes with F, so that could be either A or C. B is out. We know they're similar, so D is out. B goes with E, and this one B goes with D, so that one's out. So it has to be C is going to be our correct answer for that one. Okay, same thing here. We've got to figure out, we don't have any angles, so if they are going to be similar to each other, it's going to be by side, side, side. Okay, so in order for this to be side, 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 all my sides have to be proportional. So is 10 over 8 equal to 20 over 16 equal to 15 over 12? If we put them all into lowest terms, 5/4, 5/4, and 5/4. So yes, side, side, side works. If they were to ask for our scale factor, it would be that lowest terms, 5/4. Okay, again, we have three sides. Are they going to be proportional? 6 goes with 3, 8 goes with 16, and 9 goes with 18. So yes, they are all 1/2, or actually, sorry, this one was upside down. This one should be 3 over 6. So they're all 1/2 for my scale factor. Again, side, side, side works. Okay, this one, if these were parallel, things were a little bit different. Remember that LK goes with KJ, so that's this one right here, and LM goes with MN. So that is this guy right here. This side is proportional to this side, and this side is proportional to this side. Okay, so now if we're going to use it, we can say 26 is to 13 as 24 is to x. So now if we cross multiply, we have 26x equals 312. That's going to give us x is equal to 12 right here. Okay, this one's a little bit different. You can't go by it. Now you've got to go by triangles. So little triangle, 26 over big triangle. Now you have to add these together. 26 is to 39 as little triangle, 25 is to big triangle, y. So a little bit different. So now we've got 26y equals 975, and y is going to give us 37.5. So be careful with that second portion of this. Sorry. Alright, convex polygon. Remember, concave means it goes in. So B is out, A is out. Okay, and remember, a polygon, it has to have straight sides. So D is out because it's got that curve. And our convex polygon is C. Oops, skip one. Alright, sum of the interior angles of a regular triangle is 180. So 180, remember regular means all the sides and all the angles are going to be congruent. Okay, triangle has 3 angles, so 180 divided by 3. Each angle is going to be 60 degrees. Okay. Sum of your measures of a regular polygon. How many sides does this guy have? I numbered them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So this is where you have to use your formula, n number of sides minus 2 times 180. So we have 10 sides minus 2 times 180. So we're taking 8 times 180 and getting 1,440 degrees is going to be the sum of your measures of that polygon. Okay, this one we're dealing with exterior angles. Okay, so remember that the sum of your exterior angles adds up to 360, and that's on your formula sheet. Okay, so we're going to go 2x plus x plus 120 plus, this one's got that square in it, so that's 90. It's all going to add up to 360. So 3x plus 210 equals 360. 3x equals 150, so x is going to be 50 degrees. Make sure you solve that all the way through. Okay, number 27. This, how many sides does this have? It's got 1, 2, 3, 4, 5 sides. So to figure out what these add up to, we have to go 5 minus 2 times 180, or 3 times 180 is going to give us 540 degrees. So all 5 of these angles have to add up to 540. So take your 540 minus 77 minus 107 minus 156 and minus 149. That's going to give you x to equal 51 degrees. Okay, figuring out your table. Okay, number of sides. Remember, exterior angles add up to 360. So if it's got 4 sides, you're going 360 divided by 4 to get 90. Divided by 5 is going to give you 72. Divided by 6 is going to give you 60. So now 360 divided by 8 is going to give me 45 degrees. And 360 divided by 10 is going to give me 36 degrees for each exterior angle. Alright, so on here, find the measure of A. Again, how many sides? 1, 2, 3, 4, 5. So again, 5 minus 2 times 180, 3 times 180. This is giving me 540 degrees again. Subtract 113, subtract 91, subtract 93, subtract 117, and we get angle A to equal 126 degrees. Okay, area of a square. Remember that we can either take side squared for a square, or we can go base times height. Since it's a square, if this side's 11, this side's going to be 11, so 11 squared, or 11 times 11, we end up with 121 feet squared. Okay, remember, your label is feet squared when we are finding the area of figures. Okay, so now we've got a rectangle, base times height, so 14 times 7 is going to give us 98 centimeters squared. Don't forget to label your answer. Alright, Now we've got two different rectangles together. This one's 2 by 2, so that one's 4. This one, be careful, because we have, this is 11, but this is 2, so this is 9. And this over here is 7 plus 2, so that gives me 9. So the area of this one is 81, so 81 plus 4 is going to give me 85. And since we don't have a label, we just leave it as 85. Okay, I did this one wrong on your key, so make sure you go by the video, because it is going to be wrong on your key, number 32. Alright, area of a triangle, 1/2 base times height, so don't forget to divide it by 2. So you've got 28 times 8.8. Make sure you divide that by 2, so now your area is 123.2 yards squared. Again, area, base times height. Our base is 10. Our height, remember, has to make a 90-degree angle, so our height is 8. Don't forget to divide by 2, so this one's going to be 40 feet squared. Okay, area of a trapezoid, that's what this is. So yes, some of you, I'm sure, went triangle here, rectangle here, which is definitely something you can do, but the faster way is going to go 1/2 times height multiplied by base 1 plus base 2. So you've got 1/2 times 16.9. And then you've got to take 12.7 plus, don't forget to add your 12.7 to this side here. So that's going to end up being 18.7. So 1/2 times 16.9 times 31.4. You end up with 1/2 of 530.66. which gives you 265.33 meters squared. Alright, next problem again, you've got two of these. This part here is 16 by 11. Multiply those together, you get 176. Here, since this is 10, the whole thing is 16, your height of your triangle is 6. So don't forget to go 6 times 13, don't forget to take it times 1/2. So your triangle is only 39, not 78. Make sure your triangle is 39. So now add up your 176 plus your 39, and we get 215 centimeters squared. Okay, here we have a parallelogram, which is just base times height. So 1.8 times 5, in this case, so it's 9 centimeters squared for your area of your parallelogram. Okay, again, another parallelogram. So your base here is 77, because that's where your 90-degree angle is. So your 177 times your height is going to be 64. Make sure you use 64 as your height, not 74. So you are getting 49.28 centimeters squared. Okay, area of a rhombus, 1/2 times diagonal 1 times diagonal 2. So it's giving you the diagonals are both 18. So 1/2 times 18 times 18. Punch that baby into your calculator and you end up with 162 feet squared. Okay, number 40, halfway done. Okay, again, area of a trapezoid, 1/2 times the height times base 1 plus base 2. So you end up with 1/2 times 10 times 48, or 1/2 of 480, which is going to give you 240 centimeters squared. Okay, area of a circle, pi r squared. In this case, be careful, it gives you the diameter. So you've got to figure out that the radius is 1.2. So 1.2 squared gives me 1.44 times pi. So you can leave it as 1.44 pi meters squared, or you can multiply it out and get 4.52 meters squared for your area. Okay, then we're going circumference, which is 2 pi r. So if my diameter is 32, so my radius is 16. Okay, 2 times my radius is 32 pi meters. Okay, don't square it because now we're talking circumference. Or multiply it out and get 100.53 meters. Okay, again a circumference one, 2 pi r, so 2 times 32.2 gives me 64.4 pi. Remember, with circles you have to include your pi. Okay, inches, or multiply it out and get 202.32 inches. I will take either answer on your final. You can leave it in terms of pi, or you can multiply it out. Number 44, your radius is 8. It wants the circumference, so 2 pi r, which is going to give you 16 pi inches, or again multiply it out, 50.27 inches. Alright, now we are to the three-dimensional figures that you are going to have to use your formula sheet for. Okay, we are going surface area. Well, first they want faces and edges. So remember, faces are 1, 2, 3, and then on the top you've got 1 on the top, so 4, and 1 on the bottom is 5. So faces equals 5, and your edges, you've got 1, 2, 3 here, 1, 2, 3 on there, and 1, 2, 3 on the bottom, so you end up with 9 edges. Okay, surface area of the prism is going to be 2 times the area of your base plus your perimeter times your height. So the area of my base is 120, 12 times 10, so 2 times 120 plus my perimeter, I've got 12 plus 10 plus 12 plus 10 if I have that square on the bottom. So my perimeter ends up being 44 times my height. My height is my distance between my two parallel bases. So 44 times 3. So we end up with 240 plus 132 is going to give me 372 centimeters squared to find the area of my prism. Okay, same thing, we have a prism, except for now we have a triangle as bases. So be careful when you're finding the area of your base. Okay, you've got to take 10 times 23 and then divide it by 2. So we have 2 times 115 plus your perimeter of your base, so 10 plus 23 plus it was nice enough to give you your hypotenuse being 25.08. So your perimeter is 48.08 times your height is your distance between your bases, so 47. Okay, so we figure all this out and it's 230 plus 2259.76. So we end up with 2489.76 meters squared for the surface area. Okay. Surface area of my cylinder, we have area of my base. My base is a circle, so pi r squared. So we're going with 4 pi plus, this is the same thing, the perimeter of my circle is 2 pi r. So again, 4 pi times my height, which is 4.6. Do not forget your pi's. Oops, sorry, this multiplied by 2. So we have 8 pi plus 18.4 pi and we end up with 26.4 pi meters squared, or you can multiply it out and get 82.94 meters squared. Do not forget pi when you are dealing with circles. So cylinders, cones, anything with circles, you have to have a pi. Okay, we didn't talk about the difference between lateral surface area and regular surface area, so just get rid of the lateral. And we're going to find the surface area just like we did on a couple previous problems. So 13 times 11, we're going 2 times 143 plus the perimeter of my base, so 13 plus 11 plus 13 plus 11 is going to give me 48 times my height is 4. So we end up with 286 plus 192 is going to give us 478 centimeters squared when we're dealing with our surface area. Okay, surface area of our pyramid is now, that's volume, okay, so now it's the area of my base plus 1/2 times the perimeter times the slant height. So the area of my base is going to be 25 plus 1/2 times 20, that's my perimeter, 5 plus 5 plus 5 plus 5, times my slant height is 7. So 25 plus 70 is what we're going to end up with there. So 95 feet squared, because we're talking area. Okay. And now we have a cone, so now we have to deal with pi. Always have to include pi. Surface area of a cone is a little bit different. It's going to be the area of your base plus pi times your radius times your slant height. So in this case, area of my base, again, pi r squared, so 81 pi plus pi times my radius is 9 times my slant height is 15. So 81 pi plus 135 pi gives me 216 pi centimeters squared, or you're welcome to multiply it out, 678.58 centimeters squared. Okay, number 52. Now we are still talking about, oh, they just want x. Okay, so they just want us to find slant height here. So this is where you have to draw your triangle. Okay, we know that height, if I were to take this out, my height would be 2. Okay, you've got to be careful because this little portion right here is only half of that side, so that's going to be 1, and we're looking for our slant height. So 2 squared plus 1 squared equals x squared, or 4 plus 1 equals x squared, 5 equals x squared, take your square root of both sides, and x equals approximately 2.24 feet, if you want to label it. Okay, I am going to stop there for part 1. Okay, I will have the rest as part 2 in the second video.